So I'm warning you right now, this is probably going to be a longer video because here is one of the types of risk assessments that you can do. This is covered in many pages and frankly an example, an educational example that's in there, and I'll talk about that here in a little bit here. But in quantitative, we're going to worry about dollar signs, period. We're going to worry about calculation of financial values, losses in dollars and cents. Okay. The results can help you identify, I would hope so, the priority of the different risks and also identify the different effectiveness of the controls. Really, to be honest with you, that you should already know. I've hammered that in a couple of times. Here's the terms to know, and I'm stopping right there at the bottom here. These are terms to know. These are not super hard terms. That's the good news. But they're going to start being used in calculations, very simple calculations. There's barely any math in this, to see where our dollars and cents are really going. I try to go over a little example here at the bottom, but then I'll have another example towards the end that goes over the whole darn thing. So bear with me here. So terms to know, first is SLE, which is single loss expectancy, and that's the loss expected from a single incident to that device or whatever component it is. And that's going to be marked in dollar signs. The asset value is just that. How much is that? I'm going to say laptop because the laptop is used quite a bit in the book. How much is that laptop worth? Now remember, there's something that I really should put in there called depreciation. Things depreciate over time. My laptop right now that I'm using is 5, 6 years old. It's probably could buy a new one and not, but anyway, you know how that goes. So, exposure factor. How much of the asset is exposed to the threat? Maybe minimal, or maybe you've put a lot of safeguards on it already that it is minimal. That number is going to be between 0 and 1. Now, I want to make sure this is perfectly clear. It's being highlighted right now. But it can be a decimal point from literally 0 to 1. 0.1, 0.2, that type of thing. So that's going to be an interesting number when it comes to the exposure factor. Because of that, that expected single loss expectancy number is usually going to come down because, again, hey, this has some type of factor where depreciation is going to happen. So my laptop example. If a laptop is stolen, then 100% of the asset is lost. Then it would be a 1. But since the loss is a total, stays the same, the total single loss expectancy is going to be 100%. But what if I had insurance on the stolen laptop? Replacing the laptop at 10% of the original cost, that's 0.01, so for only 10% of the single loss expectancy, that's not too bad, okay? Is it worth protecting even more if you have, well, 90% of it is covered? Probably not, okay? So these two are really, really close, so we have to be very careful here. The annual loss expectancy is the number of times the incident is expected to occur in a year. Now, by the way, you can use past history on what's been done before or something of that nature to kind of give you this number. Again, this should have been a process that they've already had some data with, let's put it that way. But then you have the annual rate of occurrence. How many times per year might this loss occur? And that's guessing, but it is looking at past history on this. So how many times a laptop's been stolen or whatever, that's going to be important. Now, how do these all lay out? Well, you'll see the equations down here. ALE, which is our annual loss expectancy, and that's why this is different, okay, equals our SLE, our total loss expectancy, times the ARO. So again, these are why these are slightly different between the two, okay? Now, how much is it going to be to how many times? That's what I'm expecting. So again, that's why these are very, very close in consideration here. Our SLE, by the way, our single loss expectancy, is going to be our AV, which is our asset value, times our EF, which is going to be our exposure factor. Is there insurance on it? Do we have to cover everything about it? That's how we're going to come up with these type of numbers. So notice, by the way, in reality, I need to do the SLE first because it's then included in our AL or in our overall annual loss expectancy. Whew. But notice the math's not super hard here, but to understand what is happening between all of it, that's why we have a lot of our key terms to know. A couple more items that we'll have in the report quantitatively is the safeguard value. How much does it cost to mitigate that risk across the system in our organization? That's going to be something we're going to need to research, look at other companies, have other companies come in, do their sales pitch, see how much they can really save us, and notice I'm rolling my eyes. But anyway, that's going to be a part of this. And then the benefits of this is, frankly, money. How much money is this really going to save either in reality or theoretically? Because again, if you find a vulnerability that's a high risk, then it's probably going to be tapped. And if it's expensive, it's probably going to happen. But notice the word probably. So what happens, it really becomes that simple math problem that I just went over before. It's going to be included in all this, and that's why we have the formulas used here. But we're going to do this in a cost-benefit analysis, in a CBA. That's what you can look up when you Google something. We have to make sure that we have accurate values for all of our items, especially the safeguard. Boy, anyway, there's been mistakes there that let you calculate all of that in the CBA in order to make, well, management's also going to have to deal with all of this. And they're going to ask for details. They're going to ask for how much is this going to cost? How long is the protection for? What is our insurance for this? They're going to ask money questions about this, and that's frankly why you're going to have the benefits in the CBA to answer all those questions. There's going to be some limitations that we have to think about as we're building our report. Limitations, accurate data isn't always available. When you're trying to figure out what the ARO, the reductions are and everything else like that, there's going to be some fudge factor. You will have to talk to your team and the overall stakeholders in this on how you want to manage when it comes to pricing and items like that, because as you know, things always go up, they never go down. And we also have limitations is people. People, if they don't enact and use the controls, then, well, the safeguards, even though they were bought and put in place and were intentionally for good, if they're not being used, then, well, frankly, it's not really worth it, is it? So that we talked about that in automation and some other things like that, but you can't do that for everything. So that is another limitation that we have to worry about. The CBA is not the last part, but it's one of the most important parts because it talks about money. This is going to be a fiscal analysis to the upper management. This is where you get their heads involved here and they know exactly what's happening by the decisions that they make later on. And we'll talk about that here in a second too. Now, this uses a term of how much money we're going to lose if safeguards are not put into place to mitigate the loss. So that means the cost of the safeguard, this means the annual rate of occurrence with the safeguard, the annual loss with the safeguard. These should be, hey, this should be good news, right? For this last part is the annual loss expectancy with the safeguard less than the cost of the safeguard. So is the safeguard worth it? Now, by the way, it may be less, but it may not be a lot less. So is it really worth the hassle of installing? Is it really worth the time it takes to put everything in there? That's what this is going to go over and see what are the benefits. Is it really worth it? If it's not worth it, then we put it as a low priority because there's nothing much we can do about it. If there is a significant difference between the two that should save us a lot of money, then obviously it should be higher in the list and have a higher priority in our overall management of the risk. This is an educational example of one aspect of your risk assessment. This is just talking about laptops. Your assessment should have a heck of a lot more risk than just this. But this is still worthy, and notice how overall it's actually pretty simple. There's not a lot of math to this. I know it looks like there is, but honestly it's not. And the overall logic to this is pretty simple because remember, Upper management usually isn't all that smart anyway. So we want to keep it simple, but what they're going to worry about is the ALE. That's what they're going to worry about. They're going to worry about how much will this save us, and that's what this bottom part is. So the scenario is the company uses laptops for employees, each of them worth about $2,000, and they send about 100 of them out to their employees, and they lose about 4 per year. And by the way, notice, this is history within the organization that's already happened. We should be able to get details like that. So what's the SLE? So it's $2,000 since it's going to be a total loss and there's no insurance on it. So each laptop is $2,000. Now again, there should be some depreciation, especially with laptops and something like that, that the book really doesn't go over, but it is something to think about. We're going to have our ARO to be 4 laptops per year. That's our annual loss. And then our overall loss, how much it's going to cost us, is about $8,000 a year. So the top part is very similar to what we had with our AL and then AL with the control. Now, by the way, this is with the control, so that really should be highlighted here, is that with adding laptop locks, of all things, they only expect to lose 1 per year. I'm okay with that, but still. So that's going to cost us, if we lost only 1 laptop, $2,000, okay? So that means that we're going to be savings with the control is $6,000. That's if this number for the estimate holds out okay with the locks that are in place. So the safeguard value was $1,000. We end up spending that money to do the locks. Otherwise, we're going to have a realized savings of about $5,000 from all that because, frankly, hey, we knocked down the number of incidences that should happen. Otherwise, we're replacing $8,000 worth of stuff every year. Here, so the company is spending $1,000 to save over $6,000 with the estimated control in place and the estimated number of times that the incident or the risk is going to occur. Now, going back to the estimation. The estimation with the control is probably, well, there's some research that was done with that. I don't think the author specifies in this particular educational example, but that's something that you need to look into. There's going to be research out there on putting locks on computers, not locks, but maybe software locks. What did that save? There's going to be information out there on that you're going to have to do some research with, and that's what your team is supposed to help out with. So while this is an educational example, it does show you the steps, but there's some things in here, like the estimation, that it's going to require further research that the book doesn't go into too deeply or at all, but it is going to be something that you would have to do in a real risk assessment.